Hello everyone. In this video we shall discuss about the solution of few more examples of type 2 partial differential equations which are non-linear and of first order. So here is the first example, p cube plus q cube equal to 27z. We observe here that these two are the non-linear terms and they are of the first order. Therefore the given PDE is first order non-linear PDE and it is containing only ZPQ. Therefore, it is of the type number 2 that we have to identify at the beginning before going to solve the problem. So we have identified it and then we have to call the differential equation as equation number 1, and as per the method of solution, it is our duty to consider one important substitution, that is u equal to x plus ay, that is. So this is an important substitution, x plus ay we have to take, and in the previous video I have explained you, if we do this substitution, the value of p becomes dz by du. In fact, the value of p is dou z by dou x. That by using the chain rule can be written as dz by du after simplification. Please watch the previous video for the explanation regarding that. And the value of q becomes a into dz by du. So we have to substitute these two things into the given PDE 1. Therefore 1 implies dz by du whole cube plus a into dz by du whole cube, and on RHS it is 27 as it is, z as it is. So this is the form of the equation which we are getting from the given PDE. So what we are getting here, we are getting an ordinary differential equation which is though non-linear, but it is an ordinary differential equation. It can be handled very easily. So now we have to simplify the terms over here. Dz by du whole cube, dz by du whole cube is a common factor. Let us write it outside, dz by du whole cube. When we take it outside, here within the bracket remains 1 for this plus a cube for this, because a into dz by du, it is whole cube, therefore it is a cube remaining over here, and then on RHS as it is, that is 27 z. Now it is to be transferred to the right hand side, so it is dz by du whole cube, let us write it as it is, and on RHS it is 27 divided by 1 plus a cube. Let us keep it as it is in one bracket, and z outside here. So this is the thing we are getting after transferring this term to the right hand side. Now let us take cube root on this. So as to how, if we take cube root on this, it becomes dz by du. Cube root and cube cancels, only dz by du remains on left hand side, whereas on RHS it is this bracket whole to the power 1 by 3. Cube root stands for this thing, that is 27 by 1 plus a cube as it is, and here this z should be written as z to the power 1 by 3. So how did we get this thing? By taking cube root on both sides. So we got this particular thing. Now we are observing here that the variables can be separated. This z to the power of 1 by 3 can be taken to the left hand side. So as to how, dz divided by z to the power of 1 by 3 equals to 27 to the power 1 by 3. Cube root of 27 is 3, because we know that 3 cube is 27. Therefore cube root of 27 is 3 divided by this particular thing, that is 1 plus a cube, cannot be done anything to this, keep it as it is with its whole power 1 by 3, and this du to be multiplied on the right hand side in the numerator. So now we are having this thing, and it is now very easy to integrate. When we integrate, while integrating, this z to the power 1 by 3 can be written as z to the power of minus 1 by 3 in the numerator, dz as it is, and this 3 divided by 1 plus a cube to the power 1 by 3 should be kept outside the integration because it is a constant and it is integration of 1 with respect to u, that we shall write in the next step as u. That implies z to the power of minus 1 by 3. Minus 1 by 3 plus 1 divided by minus 1 by 3 plus 1 we have to write. That is z to the power of minus 1 by 3 plus 1. So minus 1 by 3 plus 1 is actually 2 by 3. So it is going to be z to the power 2 by 3 divided by 2 by 3 equals 3 divided by 1 plus a cube whole to the power 1 by 3 into integration of 1 with respect to u is u plus some constant of integration c. Let us take it here. Now this 2 by 3 we can cross multiply so as to have z to the power 2 by 3 on the numerator equals to this. When it comes to the numerator, it becomes 2 by 3 here into the bracket 3u by 1 plus a cube whole to the power 1 by 3 plus c as it is here. And now it is time to simplify. If we want, we can put the answer in a systematic way, that if we want to put it like z, so let us write it as z equal to, because z is the unknown of the differential equation, z is equal to, that is this power when it is transferred to the other side it becomes 3 by 2. So it is 2 by 3 to the power 3 by 2 into the bracket, this entire bracket whole to the power 3 by 2. Let us write down, and the quantities within the bracket should also be replaced. U by its value that we have observed here in the given problem, that is in the given for the given problem, to reduce it to the ODE form, we have taken this substitution in equation number 2, u equal to x plus ay. So let us write down the value of that here, that is x plus ay divided by this bracket 1 plus a cube whole to the power of 1 by 3 as it is plus c as it is. So this is the required complete integral because it is containing two arbitrary constants. So it is the solution of the given PDE. So easily we have obtained it. So this completes the first problem. So this is the question here to solve the PDE given like this. And we observe here that p square q square terms make the differential equation non-linear, and since they are of first orders, p means dou z by dou x, q means dou z by dou y, the derivatives are of first order and the non-linear and containing only z p q terms. Therefore these are belonging to the type 2. So the type 2 differential equation we are having here in hand. Let us call this equation as equation number 1, and as per the method of solution we have to make an important substitution. U equal to x plus ay. X plus ay is an important substitution we have to make here, and with this substitution p value becomes dz by du, and q becomes a into dz by du. One can refer to my previous video for the explanation regarding this substitution. So here I am substituting the value directly. Now if I substitute these values into equation number 1, then equation number 1 takes the form z square into the bracket, p value is dz by du whole square, its square is there, p square is there, into z square as it is, plus q square is a square into dz by du whole square. Let us write down here it on LHS, and on RHS it is simply 1. Now we have to simplify here by taking this quantity outside. So when we take this quantity outside, it becomes, this implies z square into dz by du when it's with its whole square. When we take it outside, within the bracket here z square remains, here a square remains. So it is z square plus a square within the bracket, and on RHS it is simply 1. So let us keep dz by du whole square here on the left hand side, and the remaining things are to be taken to the right hand side. So dz by du whole square which is the unknown here, keep it as it is on left hand side. Take the other quantities to the right hand side, that becomes 1 divided by z square into bracket z square plus a square, that is. So now we have to take the square root on both sides. When we take the square root on both sides, we will have the value of dz by du equals to square root of 1 is 1 divided by square root of z square is z, square root of this thing, let us keep it as it is, z square plus a square. Now we are observing here variables can be easily separated. This is a first order PDE which is very easy to solve, and this implies z into root of z square plus a square, z into root of z square plus a square dz here on LHS, whereas on RHS it is 1 into du, only du, let us keep it as it is on the right hand side. Now in order to solve this thing, we have to go for integration. So when we integrate, we have to take this symbol of integration, and this term we shall write it first, that is z square plus a square under root can be written as whole to the power half. This z we shall write it as z dz here along with this dz, and an RHS integral of 1 with respect to u we can write it like this. And in order to solve this integral, we have to make a substitution. Z square plus a square equal to t. So if we take this substitution, it means the differential of this is 2z plus 0 dz. So 2z dz equal to dt, that means z dz equal to dt by 2, that we can write over here in this place. So therefore with this substitution, the integral takes the form, the value of this entire thing is t to the power half into dt by 2, that is on LHS, whereas on RHS we can write down this as integral of 1 with respect to u is u plus the constant of integration is c. Now this t can be taken outside, 2 can be taken outside, that is 1 by 2. This implies 1 by 2 into integral of t to the power of half with respect to t is t to the power of half plus 1. It is t to the power of 3 by 2 divided by 3 by 2 equals to, on RHS it is u plus c as it is. Now this 2 cancels with this 2, and this 3 can be cross multiplied, so as to have t to the power 3 by 2 equals to 3 into bracket u plus c, and we want to substitute back the value of t. T value is z square plus a square whole to the power, that's all. Whole to the power of 3 by 2 is here, we shall keep this as it is. So t value is z square plus a square, we have substituted back here from this expression. So now on RHS it is 3 into bracket u value is x plus ay plus c, let us keep it as it is. So we can stop at this moment, or even if we want we can proceed further to put the solution in our desired format. So let me stop at this point, and let me call it as the required complete integral of the given partial differential equation of type 2. So this completes the second problem.